So viewers, today I will explain about fire combustion. So for fire combustion, first time you have to know about what is the fire. So fire is a chemical reaction of fuel with required amount of heat and oxygen. During this reaction, light and heat produces. So directly I am going to explain about fire combustion. For fire combustion, air and fuel ratio you have to maintain. So I will explain by this chemical reaction. I will explain about this theoretical chemical reaction. It is called stoichiometric reaction. So I will use methane as a fuel. Today I will use methane gas as a fuel. So methane gas CH4 react with oxygen and create carbon dioxide and water. Okay, now I will equivalence this reaction. There are one carbon is okay. There are 4 hydrogen, but there is 2 hydrogen. So for creating 4 hydrogen, you have to put there 2. So if after putting there 2, there is 4 hydrogen, there is 2 oxygen, 4 oxygen, and there is 2 oxygen. So another 2 oxygen is required. So now I will provide this side 2. Now this chemical balance is okay. Now I will calculate by molecular weight. Atomic mole 12 plus hydrogen 4 hydrogen. That means for 1 hydrogen 1, there is 4 hydrogen 4. So plus 2, and for oxygen 16, and multiply 2 to 32. So there is 16 plus 64. So if I give 16 by if I divide it by 16, so what will happen? 16 divided by 16 plus 64 divided by 16. So 1 plus 4. If you calculate 64 by 16, it will come 4. So by this way, for 1 mole methane, you can see there, for 1 mole methane, 4 mole oxygen are required. As per this theoretical reaction, for 1 mole methane, 4 mole oxygen are required. Okay, now I will explain deeply. So you know, in the air, 79% nitrogen and 21% oxygen are available. In the air, 21% oxygen and 79% nitrogen, almost 79% nitrogen are available. You know that. So for 1 mole methane, 4 mole oxygen are required for this combustion. So 4 mole oxygen, with this oxygen, how much air is required? So if I calculate for 21% oxygen, air required, okay, 100%. For 1% oxygen, air required 100 divided by 21. For 4 mole oxygen, air required 100 divided by 21 multiply 4, 400 divided by 21. That means how much coming? It's coming 19.04. So 19.04 mole air required. For are you understand that? So okay, I hope you have understand. So now I will give this another calculation. This 21% oxygen by volume available on the air, but this is only for oxygen. But in the air, oxygen, nitrogen and argon also are available. So now I will give calculation with oxygen with air. Now I will give calculation with air. If methane CH4 plus oxygen plus nitrogen, okay, oxygen plus nitrogen, that means air react, then what will happen? CO2 plus water, same reaction will happen. If I balance this equation, what will happen? There are one carbon, it is okay, 4 hydrogen, there are 4 hydrogen, 4 hydrogen, 2 oxygen, 4 oxygen. There is 2 oxygen, there is 2 oxygen, that means 4 oxygen. For 4 oxygen you have to provide this 2. You have to provide this 2, but in the air, already you put this 2, but in the air, nitrogen available how much? 79%. You know this, nitrogen available 79%. So in this 79%, how much oxygen? 21. Okay, you see this 21% oxygen. So in 21% oxygen, nitrogen available 79. So 1% oxygen, nitrogen available how much? 79 by 21. That means how much? 79 divided by 21. That means 3.76. 3.76. So 3.76% nitrogen are available. So if I can give this 3.76 nitrogen, so what is the reaction will happen? This reaction, there are 3.76 nitrogen multiply with 2. So 3.76 multiply 2, that means 7.52 plus 7.52 nitrogen will produce, and it will not react, and it will go out on the atmosphere. So now I will show this reaction balance. So for methane, I already show you. For methane 16, and for 2:2 oxygen bracket, oxygen 32 plus nitrogen 3.76 for nitrogen. It is, I will explain again. For methane already I have show you 16 and 2:2 for oxygen. For oxygen 32 plus 3.7 nitrogen. Okay, for nitrogen 14 multiply 2, so 28. So that means how much coming? You can see here 137.28. So 137.28 multiply 2. How much coming? 274. Sorry, 274.56. If I divide it by 16, here will come 1 plus 274 divided by 16. So how much will come? You see 1 plus 17.12. So that means for 1 mole methane, you can see here directly this result coming air, oxygen and nitrogen in air. This is air. Methane directly react with air. If methane directly react with air, what will happen? For 1 mole methane, how much air required? So as per calculation 17.12, that means 70.13 air is required. You can see here for 1 mole methane air required 17.12. So I hope this video you have understood. If any confusion about this air and fuel ratio, so please comment me. I will try to explain deeply. I will try to explain more. To fill up the triangle, without complete triangle not possible to fire. So as per triangle, you know, this is a triangle. In this triangle, which equipment, which product are required? First time you have to give fuel, after you have to give oxygen, and after you have to give heat. If three element or three product are present, that time only possible fire, otherwise fire not possible. If anyone cut fuel or oxygen, anyone cut, that time fire will cut off. Like this, I will give one easy example. If you lighting the candle, and after some time if you give this glass on the candle, if oxygen not entry on the candle, within short time this candle will light off, because there are not present oxygen. So that means without oxygen not possible to create fire, without fuel not possible to create fire, without heat also not possible to create fire. But if you put fuel, oxygen, heat, this is okay. If you put like this, here is fuel, here is oxygen, and here is heat. that time also not possible to fire, because this is all are different side, not connected, need to chemical chain reaction. Without chain reaction, fire will not happen. So I hope you understand. If not understand, please comment me. I will try to explain about this fire combustion. In our boiler we are maintaining like this. Okay, for 1 mole methane we are providing 17.2 or 17.3 mole air. Another thing, if anyhow oxygen is reduced, there is one flammability limit, you know. So it is called, if oxygen percentage more reduced or fuel more reduced, or oxygen percentage more increased and fuel more increased, that time fire will stop. It is called flammability limit. It is called flammability limit. Normally lower flammability limit 5. If oxygen percentage coming 5 mole for 1 mole methane, that time fire will stop. Another things, if in your plant, in your fire, if in your fire oxygen percentage more than the theoretical reaction, it will call lean solution. If percentage or air percentage like this, if for 1 mole methane air, then if available 19, it is called lean mixture. It is called lean mixture. And if 1 mole methane provide 9 mole, it is called rich. It is called a rich mixture. Because why? This gas is always rich. Gas is always high price. That's why if anyhow gas percentage more than oxygen percentage as per ratio, it will call rich mixture. If oxygen percentage more than the chemical ratio or more than the theoretical ratio, it will be called lean mixture. So viewers, I hope this chapter is understood. If you like and comment my video and subscribe my channel, I will try to give more videos about this industrial plant related. Thank you viewers. See you again.